and today in this video, this will be a continuation of an earlier video I've made on the earth processes and landforms. So, and in that earlier video, we talked about waves. We've talked about water. Yes, we talked about the water and water action, how water affects the environment and forms different landforms. It's formed different landforms. And then we have to talk about the upper course, the middle course, and the lower course of the river. That's if you don't watch it, you can go and check for it on this channel, GlEDUzownë, Global Education Zone or GlEDUzownë. So and then today in this second series, we'll be talking about the action of wind, the action of glacier, and the action of waves. So let's start from the action of winds. Now in winds, we have to talk about the fact that wind also has power, because wind is air in motion, right? Well, in the previous section, I said water is the action of water is water in motion. So rivers are water in motion, but wind is air in motion. So and this air in motion also has its own energy, because it has speed, and because kinetic energy is expressed in terms of your speed. So now this wind has speed, and then we'll talk about wind. We'll talk about wind energy and the action of wind. We'll mostly talk about what we have as our desert. So and then if you are very keen in geography, you would have known that most hot deserts are occurring in between 15-degree north and 30-degree north and south of the equator, right? So now those deserts, they are characterized by cold currents. I'm just giving you a revision just in case you don't know how deserts are formed. So and then they are characterized by cold currents, and then most of them, they have little or no precipitation. So now the reason why when we talk about wind, we often talk about deserts, is because this wind, the action of wind, is more pronounced in deserts, because these deserts, they have little or no vegetation and covering to protect the soil. So and then the wind is just like the wind has a lot of 100% access to the soil surface, and then the wind has the whole ability to do what is called erosional processes. And then the wind also has erosional processes, the wind also has depositional processes, the wind also has transportational processes, just like your river. So and then we're talking about those processes right now. So and then let's talk about the before that, let's talk about types of deserts. So and then we have what is called the egg or sandy deserts. So that's what the deserts are full of sand and sand dunes. We have hamada or rocky deserts. Then those are the deserts that are full of rock. Then we have reg or stony deserts. Then we have badlands. Then we have mountain deserts. So I can give a very good example of the egg or sandy desert, ERG or sand desert, and that is the Sahara desert in the northern Africa. So and that Sahara desert is a sandy desert. We also have in different other regions, we have rocky deserts. So and then rocky deserts are mostly due to vicious erosional processes. Then let's move to action of wind. So and then wind has different action. It has what is called deflation, abrasion, and attrition. Now deflation is when the wind lifts and blows away sand. When the wind lifts and blows away sand from a place, it's called deflation. And then when you lift something from somewhere, you are leaving behind a hole or a space or a cavity, and those holes are known as deflation hollows. So when the winds perform deflational activity, it leaves behind deflational hollows. Then talk about abrasion. Abrasion is when the wind carries those particles that are carried away by the wind that are transported. They are used to blow away, they are used to erode other particles, other land features, just like your mountains. So in your deserts, you can see that your wind mostly erodes or wears away those mountains, not because of the wind itself, but because of the particles. Those particles, they are constantly hitting those mountains, they are hitting those landforms, and then they are wearing them away. That is called abrasion. Then we have attrition. Attrition is the process whereby wind-borne particles collide with one another. So and in that attrition, the wind particles themselves, those sand particles, they are wearing away each other as they are being carried by the wind, and they are becoming smaller and smaller and smaller till they finally get deposited. So then we have different features of wind erosion. We have what is called rock pedestal, and rock pedestal often involves horizontal bands of alternate light and of hard rock and soft rock. So and then it's basically something like this. So you are often have a wide place, a thin place, and a wide place for your surface. So and this wide place is the hard rock. This hard rock is difficult for the wind to erode. Then we have the soft rock in between. Then we have the hard rock on top. So then if you watch documentaries of the Sahara desert, you will see these landforms. Everyone that is here, they were not made up by your geography teacher or your geography textbook. So every one of them exists. So your rock pedestal, that's how it looks. Then we also have your Zugins, and then Zugins is basically when you have, it's also like your rock pedestal, but instead of the wind cutting it from the side, the wind is cutting it from the top. So now in your rock pedestal you have horizontal, just like your rock pedestal. In your Zugin you also have horizontal bands of hard and soft rock, but then your wind is cutting into, and then you have what is called your lines of fissures. So basically it's just like when you have something like this, then your wind is cutting into from the top. So and then after your Zugin you also have your Yadang. So and that's your Yadang is just like your Zugin, but instead of having your horizontal bands of hard and soft rock, you have vertical bands of hard and soft rock in your Yadang. So in Yadang also the wind is cutting from the top, but in this time around you have your vertical band of alternate layers of hard and soft rock, and there are no lines of fissures. So you have your hard rock, hard, soft and hard. That is called the Yadang. So and these are all features of wind erosion. Then after that we also have mesas and booties. So and then these mesas and booties, they are also like when your wind hits a landform or a mountain, and then your wind is eroding that mountain. When it erodes it becomes a mesa. Then when it erodes it to a very very small part, it becomes a booty. So and then we have your inselberg. Inselbergs are just like they are isolated rocks formed when you have a hard remainder of your surrounding. So when you have an area of land and then the wind has eroded that area, then what is left behind is called an isolated landform, also known as an inselberg. Then we also have ventifacts and decanters. So they are also like erosional features of wind. We also have then we have wind depositional features. So and then you can see that as the wind is eroding everything, it is transporting what is eroding, and then at the final stage it is depositing these things. When it deposits this thing, it forms two major features, which are your dunes. And these your dunes, you have after your dunes, we also have loess. So these two major features are found when your wind deposits material. So in your dunes, you have your Bachan dunes, and then you have your safe or longitudinal dunes. So in your Bachan dunes, they are very very common in your Sahara desert. So it's basically you have like a part of the part of it where you have it is deposited on this side. So and then when they are deposited on this side, it forms a hole on the opposite side. That's your backhand dune. Then you have your safe dunes when your wind is depositing in a longitudinal or straight lines, and your safe dunes, safe dune or longitudinal dunes, they are parallel to your wind direction. Then that is most of what we have to cover on wind action. Then we also have glacial action. So now we talk about terms related to glacial action. We have what is ice. Then a glacier is basically is highly frozen ice that is kept at very much below the freezing point of water. It's just water, but it's very much frozen water. So then we have ice. So and then your ice is basically water below 0 degrees Celsius. Then we have your glacier. Your glacier is basically your ice which is frozen and it is also moving. So then we have your glaciation, which is the wearing away of the earth by glaciers. We have your snow, which is the frozen water vapor which fall like crystals from the atmosphere. We also have your snow line, which is the lower limit of perpetual snow on a mountain. So and then that snow line is basically the lower limit where snow forms on the top of a mountain. Because you should have heard of your lapse rate. In your normal lapse rate, it says that as you go up, your temperature gets lower. So and then when it gets to a stage where your temperature has hit 0 degrees Celsius, then the water vapor in the atmosphere will be changed to ice. So and then that ice will form a snow cap. And then the lower limit is called the snow line on a mountain. Then we have your snowfield, which is the region permanently under snow. So and then action of glacier. The glacier performs three major actions, which are sapping, plucking, and abrasion. And this sapping, plucking, and abrasion, they are simply like the other ones we've talked about. So sapping is the breaking up of rocks. Your plucking is the tearing away of blocks of rock. So after your sapping, after you broke up the rock, you have your plucking, which is tearing the blocks away, and then they are being transported with the glacier. And then we have your abrasion, and so on and so forth. So we have features formed by glacial actions, and then this you don't really have to they are not really common because this occurs between the Arctic and Antarctic circles, because the Antarctic circle contains a lot, like 90 or so % of the amount of glaciers in the world. So most of the time when we talk about this glacier, we are focusing on the Antarctic circle and also the Arctic circle in the southern pole and northern pole respectively. So and then this Features include striations, which are scratches. We have sects, which are deep and hollow. When the glacier transports those materials, so it leaves back a hollow, just like your deflation hollow from your wind. So when you have your when you have a place that is left behind by your erosional action of your wind, it is called deflation hollow. But when it is left behind by your glacier, it is called a sec or your cories. Then you have your arids. So these are like oppositely facing cories. When the cories are facing each other oppositely or at an angle, it's called an aris. And we have a pyramidal peak, and so on and so forth. We have different actions. And then lastly, for today's video, we have to talk about your wave action. So and your wave action is just like your water action, but in this case, your wave action has to do with your seas, your larger bodies of water, and your oceans. So in your wave action, let's talk about the terms associated. We have your wave. Your wave is basically turbulent water that is moving at a very high speed and a very high potential energy. And we have your tide. Your tide is the alternate rising and falling of your sea level. That is the tide. Then we have your currents. Ocean currents are basically the movement of water with a harmonic pattern. And then we have shore, which is the space between your beach and your ocean. Then we have your beach, swash, backward, and so on and so forth. So there are three major actions. Just like your water action, you have three major actions of your wave. These are corrosion, where you have the wearing down of the cliff. So and then this often occurs in the interface, as I stated earlier, the interface between your water and your sea. So and then most of the time when you have an interface, that interface is called a shore. Then when your shore has a high elevated surface, it is called a cliff. And then that cliff, when the wave wear away the cliff, it's called a corrosion. Then we have attrition, is the breaking down of the materials on by the wave. Then we have hydraulic action. So these are still the same processes that I explained earlier in part 1 of this series. Then we have solvent action, when your wave dissolves rock chemicals on the shore. So then let's move, without wasting much time, let's move directly. We also have features produced by wave, but they are not difficult for you to grasp. If you have the geography test, we can easily check it out and understand it better. Then let's move on to three major coastlines formed by waves. Then we have these three major coastlines. They are the rear coastline. We are the then we have fjord coastline. Then we have the Damatian coastline. In that your rear coastline is mostly found in your Sierra Leone. Then your fjord coastline is found mostly in the Europe side of Europe. Yes, in Europe, let's say Norway and so on and so forth, all those European countries. Then you have a Damatian coastline. It's also found in North and Southern America. So then your rear coastline is basically when you have a submerged coast. So and then you have your wave action. So because of the action of water, the water when the tide rises and then your wave, your coast becomes submerged. So and then when it's submerged, it occupies the area of the land that is below the sea level, below its new level. Now when you have just like nowadays we are talking about the effect of global warming, right, which is rising sea level. So and then when you have this rising sea level, what's an important aftermath of this is that most of our coasts become submerged by water. And then when you have that submerging, you might be having a process known as rear coast, and that's rear coast. It's the wave the water kind of passes through and the hollows and the spaces. So and then this kind of coast is not usually very deep. Then we have your fjord coast, and then your fjord coast is a U-shaped coast, and they are often glaciated. So and then they are often deeper, and then they are they are actually shallow. They are shallow, and then they are glaciated. So the difference between rear coast and fjord coast is that fjord coasts are shallow and then they are glaciated. Then we have a Damatian coast, and then the Damatian coast is formed. Is unlike the others. It is formed when it goes parallel to the headland. Then when you have your sea and your water, so your Damatian coast goes at parallel to the land and then at perpendicular at 90 degrees to the sea. So it goes in a straight line and then it erodes into the land. And then that is most of it. That is all for this video. Thank you for watching, and if you want to gain more about this topic, you can check the description of this video, chat me up on WhatsApp, or you can go and contact your teachers or your textbook